Hello everyone. Today in this video we are going to discuss some of the examples in which we are going to apply the different congruency criterias that we have learned in our last class. So let us begin. So the first example says that in figure, so let us see what is the figure. So this is the figure. In figure, OA is equal to OB and OD is equal to OC. This is given to us. Now we have to prove that the triangle AOD is congruent to triangle BOC and AD is parallel to BC. So as you can see clearly in the figure, the things which are equal are already marked and the things which we need to prove is given to us. So since we are required to prove that triangle AOD is congruent to triangle BOC. So first of all, let us consider those two triangles. So in triangle AOD and triangle BOC we have, so if you see carefully in both the triangles, what things are equal here? First of all, OA is equal to OB because that is given to us. Next you can see one angle is there in between. If you can see this angle AOD and this angle BOC. What kind of angles they are? Yes, they are vertically opposite angles. So they will be equal. So angle AOD is equal to angle BOC. Again, we are given that OD is equal to OC. So this is also given to us. So now clearly we can say that triangle AOD and triangle BOC, they are congruent by side angle side congruence rule. Clear? Now our next task is to prove that AD is parallel to BC. Now AD and BC, we can prove them to be parallel only if we can show that there is some angle which we know as the alternate interior angle are equal, because we know that if alternate interior angles are equal, then the lines are parallel. We have learned this in some theorem in chapter number 6. So let us do that then. Now since triangle AOD is congruent to triangle BOC, so we know that if two triangles are congruent, then their corresponding parts are also equal. So we can write angle OAD is equal to angle OBC. So if you see carefully in the figure, this OAD, this angle, and this angle OBC, this angle, these two angles are equal. Now if you see again carefully, these two angles are what kind of angles? Yes, they are alternate interior angles for the line segment AD and BC. So since they are alternate interior angles and they are equal, so you can say that from here that both these lines, or you can say line segment AD and BC, are parallel. So this proves our both the conditions that we need to prove in this question. Clear? Now moving on to our next example. Our next example says a line segment AB and a line L are perpendicular to each other, or you can even say that it is given here that L is the perpendicular bisector of the line segment AB. So let us see the figure, it will be more clear to us. So this is the figure. As you can see here, the line L is a perpendicular bisector on this line segment AB. Perpendicular bisector means not only it divides this angle into two equal perpendiculars, as well as it divides this line segment into two equal halves. That is, AC will be equal to BC, and this angle PCA and angle PCB, they will be 90 degree each. So this is what is meant by perpendicular bisector. Now here we have to show that P is equidistant from A and B. So this point P is equidistant from A as well as from B. That means we need to show that this length PA is equal to PB. Clear? So let us first of all write what is given to us. We are given that line L is perpendicular on AB and passes through C, which is the midpoint of AB. That is, AC is equal to BC. So already I said to you that since it is a perpendicular bisector, it will divide the line segment into two equal halves. Now next, what we need to prove? We need to prove that PA equals to PB. So let us begin the proof. So in the proof, we'll consider, as you can see, it has divided this whole triangle into two equal triangles. So we can consider this to triangle PCA and triangle PCB. Now if we consider them, first thing which is equal here is AC is equal to BC, since C is the midpoint of AB. The next thing is angle PCA is equal to angle PCB, 90 degree each, since it is a perpendicular bisector. Then PC equals to PC. This line segment PC equals to PC because it is the common side. So by side angle side congruence rule, we can say that both these triangles PCA and PCB are congruent. Now, as I already said, or as I already mentioned in the earlier example, that if two triangles are congruent, then their corresponding parts are also equal. So now we can say that the side PA is equal to PB by CPCT. Clear? Next example says that line segment AB is parallel to another line segment CD. O is the midpoint of AD. Now we have to show that triangle AOB is congruent to triangle DOC and O is the midpoint of BC. So let us see the figure. So this is the figure given to us. Now here you can see that line segment AB is parallel to CD. This is given to us. Also, it is given that O is the midpoint of AD. That means OA will be equal to OD. And then we have to show that triangle AOB is congruent to triangle DOC and O is the midpoint of BC as well. So this is what is given in the question. So let us begin. First of all, let us write down what is given to us. We are given that AB is parallel to CD and OA equals to OD. Now what we need to prove? It is already given in the question that triangle AOB is congruent to triangle DOC and O is the midpoint of BC as well. So let us begin the proof. So in the proof, we will consider those two triangles only which is asked to show congruent. So triangle AOB and triangle DOC we have considered. In this triangle, since both the lines AB and CD, the line segments are parallel. So we know that if the lines are parallel, then their alternate interior angles are equal. So which are the alternate interior angles here? Yes, angle ABO and angle DCO. This angle ABO and angle DCO. We could have considered another pair of alternate angle, this also, angle CDO and angle OAB. That also would have been correct. Anyone you can consider. So these two we have considered, angle ABO, this angle, and angle DCO, this angle. So they are alternate interior angles and this BC is the transversal. Clear? Next thing is that angle AOB is equal to angle DOC. This angle AOB is equal to angle DOC. These two angles are what? Vertically opposite angles. So they are also equal. Next thing is OA equals to OD, that is given to us. So we can say that both these triangles are congruent, that is triangle AOB and triangle DOC, by angle side congruence rule. Now, as you can say that since both the triangles are congruent, so their corresponding parts will also be equal. So that gives us OB is equal to OC. Now, if OB is equal to OC, clearly it states that O has to be the midpoint of BC. Then only this is possible. So we can say that O is the midpoint of BC. Clear? So this brings us to the end of today's video. I hope you'll have understood these three easy examples from the textbook. So you can practice. There are several questions given in the textbook which are related to this congruency of triangles, which are related to the application of the different congruency criteria. So that's it then for today. Thank you and have a nice day.